it go? Did the stream pick up yet? We're about to find out. Let me just click a few more buttons here. Click. All right. Welcome everyone. We are here tonight with another episode of Dan Does Data. We're going to be looking at a library called Keras. And it's another high-level wrapping library similar to skflow. It was originally designed to work with Theano, another machine learning library similar to TensorFlow, but now Keras is usable with either Theano or TensorFlow as a backend. So whichever one you like more, whichever one you happen to have installed, you can use Keras on top of. And it makes specifying common models very similar. And we're going to be taking a look at it, and we'll see how it's similar to and different from things like skflow. I've poked with it a little bit, but I'm generally pretty new to it. So let's do the first thing. We always have to install it, and I might have cheated. I might have already installed it. So we're going to take a look at that. Sudo Pip Install Keras, that's what I'm all about. Someone's going to tell me that I shouldn't be using sudo with pip. That's okay. I'm using the old version of pip. That's fine. So I've already installed Keras, so we're good to go. You can install it too, just with pip. There's one catch. You need to update your version of Theano if you do that. I believe the version of Theano on PyPy is not sufficiently up to date. Keras actually requires the version that's on GitHub. GitHub. No, not there, not there. Theano, GitHub. And you can pip install directly from this, so that's quite nice. To install the package, see this page. Maybe I should do that. You gotta have all these requirements. You can use Docker if Docker's your thing. Update. Bleeding edge installation, that's what you need. Or something close to it. So if you pip install upgrade no deps, this line, let me paste it here just so you can see that. Pip install -- upgrade -- no deps, git plus git, /github.com/theano/theano.git. That will upgrade your Theano to the most recent version. But I've already done that because I was fighting with some things earlier. That's just an important caveat that you should be aware of. So today we're just going to take a look at some common things that you would do in Keras. We're not going to look at the ultra basics such as how do you add two numbers, how do you add two arrays, because Keras is made specifically to be a layer on top of Theano or TensorFlow. I'm choosing to use it with Theano right now. I might switch it to TensorFlow just to show how that happens. And it's not hard to switch it back and forth. In fact, they have a nice little help file. Keras.io is their homepage. You can poke around and see, like, oh, how do I switch? Follow these instructions to switch. We're not going to do that right now, though. Let's take a look at examples, because that's always the common thing. For example, the multi-layer Perceptron. They've got a thing here they build, but they don't actually have data for it. X-test, Y-test, X-train, Y-train. Alternative. I just wanted to see. I had a thing. Here we go. This fellow, FC Hollett, F. Scholle. I really apologize. Don't have your name down. This is the Keras on GitHub, essentially. They have some examples in here. We're going to start with those. And in fact, I appreciate their numpy.random seed here is 1337 or elite or elite. For those of you who are interested in that, that's just cute. All right, we're in Python 3 though, so let's just import numpy as MP. We're going to need a bunch of Keras stuff. That's what I'm going to copy and just paste in, because as you can see, it's going to give us Amnesty for free. Let's do that. Boom. Let me. Yeah, okay. Sure. So that'll download the data when we need it. I probably downloaded Amnesty about 5 to 10 times by now, but that's okay. we need sequential. That's how we're going to build the model. So a Keras model, you can either build it with this thing called sequential, which means one layer stacks into the next layer, stacks into the next, stacks into the next exactly. Or you can use a thing called graph, which says, well, this layer is going to split into two pieces, and those two things are going to do their own thing, and eventually they'll come back together. I believe it's used as what's called a DAG, a directed acyclic graph. You can just think of that as meaning every node of your graph points in one particular direction, and at no point can you end back at a node that you started on. So one node will point to another, and you won't point around to several different nodes and point back. So this is a common type of thing. You can also think of it like dependency. So that's Keras.models, Keras.layers.core. These are different kinds of layers that you can specify. So dense is the typical fully connected layer. Dropout is often used in convolutional models. You say when you're training, randomly drop out some nodes. Activation, that's the neuron activation. Not really, I don't think of it as a separate layer from the densely connected or the convolutional. But that's where you specify we're going to use the sigmoid, we're going to use hyperbolic tangent, we're going to use ReLU, something like that. Next, Keras comes with a bunch of different optimizers, such as stochastic gradient descent, SGD, the atom optimizer, and RMS prop. All kinds of fancy things. You can take your pick. And it has Keras.utils, import numpy-utils. This lets you quickly convert to one-hot format, among other things. I fiddled with it. It's actually kind of slow. From the TensorFlow tutorial, there's a much faster. They just implement it sort of directly with numpy, and that's actually faster. But in this case, it's not going to make a difference. All right, I want to see if I can just get my data going here. Let's see if we can do that. And if we can get the data, then we can just specify the model ourselves. Downloading the data from Amazon. Doesn't take too long. 30 seconds. So Keras has progress bars. This is the best thing ever. I love, love, love progress bars. So good. I don't know if you've ever had to wait for some computation and it takes forever and it's awful and no more. Now you can just you can see how much time it's going to take. They even give you an ETA. That's wonderful. So we got 60,000 training samples, 10,000 testing samples. Typical. This is the Amnesty digit classification training set, of course. That's what we look at. That's what I always look at. But when you're learning a new library, it's important to do something you're familiar with, so you can sort of gauge, well, how easy is it to do this thing? Import matplotlib.pyplot as plots. Plot.ion. And I always like to look at pretty pictures. Let's do that. Xtrain is what? Oh, right. Xtrain of 0 is 784 things. If you look at it like that. And if I reshape into 28, 28, is that going to work? Yeah, it works. And if I say plot.pcolor, and this is the number we've seen 100 times, so that's good. It's still there. All right, anything else I should be aware of? Oh yeah, this is where the categorical business comes in handy. So numpy.utils has this method called toCategorical. So if you take a look at ytrain, this is just a list of integers telling you what digit that picture is. But of course, we want the one-hot encoded format. So you want something that says, well, if it's a 5, that means 0 comes 0, 0, 0. There's 4, 1, 0, 0. You want something that looks like that to represent a 5. So you put a 1 in the index 5 position. NumPutils will let you do that. What all the stuff does NumPutils have? You can absolute import. What? I didn't even know about this. I have to learn more. What can I do with this? Return release in which this feature will become mandatory. What? Class feature. Hang on. What is? I have to learn what NumPutils. Absolute import is something I've always wanted in Python, and I've implemented myself a handful of times. Like, I just want to import a file from some random location. I should be able to do that. And yeah, there's an imp module that lets you do this. But it's kind of a pain to use, and I've written wrappers for it, but then I gotta have those wrappers around. If this thing does it, that's... From future import, absolute import? Oh, never mind. I don't think this is what I want. Never mind. I think it's to sort of import from the immediate directory. So you can import, you can say from dot import, whatever. Oh well. Alright, that doesn't matter. But the point is, NumPutils.to categorical. Yes, this will convert your digits into one-hot format. I think it's a little slow. But it gets the job done. So let's run that. NB class is not defined, right? Because NB class is 10. We have 10 classes. Because there's 10 digits. And so now you look at ytrain of 0, and you see that's what I created before, essentially. So the primary working feature of Keras is what's called a model. And the way you work with a model is you instantiate it with sequential. That's the type of model we're building. So every layer depends on the layer immediately above it. And then model has a bunch of things that you can work with. You can look at its layers. You can talk about the weights. You can give it a name. It's got a certain number of inputs, certain number of outputs. It's got a summary once you add a bunch of layers. And of course you compile it, which with Theano or TensorFlow means you compile the CUDA code, all this stuff. You can fiddle with regularization, you can use it to predict stuff. It's got a sort of scikit learn style to it, but not exactly. And if you want to add a layer, you say model.add. And then you have to tell it what kind of layer. How does model.add work? They don't tell us. Alright, well, let's look back at the tutorial and find out how model.add works. So you pass it a type of layer. So in this case, dense. So dense is a kind of layer. Fully connected layer, that is, so to speak. In fact, just your regular, fully connected NN layer. I like it, that's cute. And that takes a number of nodes that you want in that layer. Just for the sake of argument, let's say 128. And for the first layer, you have to tell it how many inputs you have. Make sure I do this right. Input shape, there we go. Input shape equals 784, because that's how many pixels we got. That's all you gotta do. And I have clearly not completed my parens. There we go, parenthesis completion. Perfect. And now we look at model. Let's take a look at model.summary. And you see we've got a certain layer. It says, what is it? I don't know what the output shape is. But I've got this many parameters, about 100,000. Which is, of course, 784 times 128. Plus 784? Plus 10. No. I guess that's plus 784? No. I was thinking there was a bias term for every guy, but there's not. I'm not sure how that sums up there. but it's about that many, and there's, I'm missing how many? 1148 minus 10352. Take a look at that. I'm missing 128. Oh, right. I have 100 plus 128, not 785. There's a bias term. Right, 784 pixels plus 1 bias term. And by bias, in this case, I mean you're always going to shove a 1 in. Right, because all of our x data is numbers between 0 and 1, so you're always going to throw in an extra 1 for every data point, just because some digits might be inherently more popular than others. Fantastic. So we just added the layer saying, hey, I want this many neurons on this layer. Well, that's great, but what do you do with all those neurons? Well, you need to activate them. So you say activation, and you pass it a string of what kind of activation you want. So I'm going to go ahead and say sigmoid. You have a couple different options. Apply an activation function. Do they talk about activation functions that I have? They don't. Let's take a look and see what activation functions they have. Activations, what do you know? Available activations. Softmax, we'll be using that later. We'll get to that. Soft plus, similar kind of thing. The standard ReLU, TANH, sigmoid. Hard sigmoid I haven't seen before, but that's interesting. Linear. On advanced activations. Activations that are more complex than simple Theano, yada yada yada, are available as advanced activation layers. So they say that, and I see a couple advanced activations. One thing I don't see is how do you specify your own activations? Because that's something you can, of course, do in Theano or TensorFlow. You can write a little function to be your activation, and then you're good to go. But I don't see how you would do that here, which is a little annoying, a little unfortunate. If somebody knows, please ping me and tell me. Leaky LU. Oh well. We'll have to. Oh wait, what source? Class leaky LU masked layer. What about? So maybe it is possible. What about if I go back? No. Okay. Hang on. If you look at the source for something like leaky RU, for example, you could probably use this to develop your own guy. In fact, this class is pretty small. What does it do? Super base config leaky ReLU. Is it like getting it from somewhere else? Like I don't know what this masked layer is. Unless for a small gradient when unit is not active. Yada yada yada. Super leaky rel. And what where's the actual git config? Like I don't see how this actually implements it. Alpha 0.3. Alpha times x for x less than 0. Negative slope coefficient. What about pre-LU? Like pre-LU is the same build. I'm not gonna spend a lot of time on this, but it's worth looking to see how to build your own, if you can even do that. It looks like maybe you can't. Thresholded linear. Like oh wait, hang on, what's this? Get output. k.absx less than. Maybe that's what the magic is. Get output. Pos dot. Okay. So if you write your own, you just got to write your own. Copy most of this stuff. Write your own get output function. Right. And that's what they've done. They've done x equals this get input and k.ReLU with its own alpha. Is this secretly implemented? Oh no. K is the back end. So whether you're using Theano or TensorFlow. And so this is some actual function in Theano, say, and you're calling ReLU with the alpha of this, which is what the leaky ReLU is. So if it's something that exists, so this is where you're directly computing something in the back end. So if you're good with Theano or TensorFlow, you can write your own custom activation functions for Keras. But that's a digression. Right now, we're using typical activation functions because that's what we do. So we added an activation function. I have too many. Model.summary, that was a mistake. Sorry, I've done something I didn't mean to do. I added the activation twice. That doesn't make sense. There's no reason you would do that. Can you remove a layer? That's an interesting question. Set input, delete layer. Layers? What if, just for the sake of argument, I say model.layers equals model.layers, and I drop the last one that I accidentally added. Does that work? Model.layers, sure. Model.summary. Oh, that's amazing. Wonderful. Wonderful, wonderful, wonderful. So I accidentally added, whoops, added a second activation, cut it out, excise it, we'll say. Okay, that's cool. I like that. Let's just go ahead and do our output now. So it's model.add, and I believe it's still dense. And we've got 10 is our input. But we want to specify, yeah, 10 is how many things we got coming out. Make sure I do this right. Yes. We got 10 things coming out. That's all we got to worry about. Then we say model.add activation. And this time it's going to be softmax, which, as you recall, is the function at the end of the typical MNIST classification problem. It converts your scores. Don't do that. It still compiles. Interesting. What is the appropriate way to remove a layer then? Let's find out. Let's ask the internet. Keras remove layer. It'd be nice if we could disable them. Can't replace freezing layers. Hyperparameter. Unsupervised learning. That's not right. Certain layers, such as yada yada, remove. We could only add a utility function similar to this to remove layers of arbitrary types. Can't replace dropout with this. No, that's not what I want. Layer when predicting. Huh. I guess maybe they didn't intend for this to be used interactively. I'll tell you what, we're going to see what happens. And if it blows up, well, that's a waste in the compiling, but that's not the end of the world. And of course, after you add all your activations, you have to actually compile it. And so that will call on Theano or TensorFlow or whatever and properly convert your Keras code into TensorFlow code to be properly compiled down to machine code. Let's make sure I'm doing this right. I'm not missing something. Ah, of course. Da-da-da. You need, of course, an optimizer. So I'm going to say, let's use stochastic gradient descent. Oh, that's not. And you have to specify the loss function. So typically for classification problems, use categorical cross entropy. This is the same as using like log likelihood, essentially. You can think of it as a very similar thing. Maybe it's not exactly the same, and maybe I'm lying, but that's okay. Let's take a look at SGD. What are our options? You can set the learning rate, you can set the momentum, decay, all this other stuff. Let's just leave it as is. Alright, Graham is warning me that Theano is going to take longer to compile. I'll tell you what, we'll run a little experiment. We'll time how long it takes to compile. There we go. We'll time this, and then we'll redo it without accidentally adding the second activation layer. In fact, I'm going to go ahead and delete delete that right now. Ooh, shoot, I didn't mean to. There we go. My fingers are so trained to, like, when I highlight a bunch of lines of code, to just Slimuck send them over to the other pane. Theano does take a little bit of time to compile. That is one thing that I've noticed TensorFlow tends to be faster at. But in the grand scheme of machine learning, that just doesn't take that much time. Maybe it takes a while to compile. Alright, what else do we need to do? We need to do while that's compiling, we're going to need to actually fit the model. That is, we're going to need to train the model. So we're going to use model.fit to do that. How do we do that again? Since I can't go over to my Python, you pass the training, input data, the training classes. What else works here? You got to tell it the batch size. I like 32, but I think they went with 128. 128. All right, we'll say 128, just for giggles. Just for giggles. They are using number of epochs equal to 20. I don't want to wait that long. Let's say 3, just to get something going. All right, there it went. How long did wall time? 1 minute 32 seconds. Interesting. All right, let's delete the model. So 1 minute 32 seconds. Although the CPU actual time claims it isn't that much. Alright, but we're continuing on our epochs. Oh, show accuracy, yeah. I want to see the accuracy. And I gotta give it some validation data. You don't have to at this stage, but if you do, it will automatically compute it. Clear previous is the method to remove a layer. Thank you very much. That was not obvious. Whoa, that is a lot faster. Okay, you're definitely correct. Clear previous. I tell you what, let's try it. Let's do the mistake. We're gonna learn something interesting here. Fix it. Model.clear previous. Let me delete the old model. Model.clear. Clear previous doesn't seem to exist. Maybe I haven't updated my Keras in a while, and I should have. Clear previous. Clear. Oh, is this something I import from Theano? Maybe it is. Might be cached though. Yeah, it could be. Either way, I probably shouldn't have in my code the obvious mistakes. Methods, clear previous, defined by a layer. Well, that's adorable. Can you tell me what it actually does? Okay, defined by a layer. Unlink a layer from its parent in the computational graph. So keras.layers.core.layer. There we go. Cannot import name. Import keras.layers.core.layer.clear. Layers containers pi line 62. Yeah, I think that's what I was just looking at. Maybe not. What are the options here? No, that's the actual layer itself. This is only allowed if the layer has an input attribute. Reset weights. Unlink a layer. So would this be from model then? Model dot. Model dot, not layers. Yeah, model dot layers, maybe. 3 dot clear previous. List index. Oh, not 3, 2. Duh. Activation object has no attribute 2. Okay. Well, Graham thinks it might be, that might have been an old thing. It exists somewhere in the documentation. Maybe if I instantiate this object. I say L equals this. And I say L dot. No, I mean, that's like a regular model, it looks like. Methods. Yeah, maybe they haven't updated documentation, it looks like. So maybe that's something they need to update. That's something to keep in mind. That's okay. We are just going to not make the mistake, of course. Why would we ever do that? We're not going to make a mistake. Doesn't matter. If you make a mistake when you're specifying your model, it's easy enough to go back and just re-specify the model. That's not the end of the world. We'll compile and boom, look at that. Not too bad. Interesting. Okay. Let's get back to fitting this data, though. That's the important part. So you pass in xtrain is your xtraining input data. Ytrain is that one hot encoded output training data. Batch size is how many images you're going to send through at once. Number of epochs, of course, is the number of times you're going to run through all of the data. Show accuracy equals true means we're going to see the validation accuracy at the end, and I think the training accuracy too. Now, in their example here, you'll notice they say verbose equals 2. I'm not going to say that. I'm going to say verbose equals 1 because I think with 2 you don't get to see the progress bar. And I'm all about the progress bar. If I get a progress bar, oh, that's a good day. That's a good day. All right, y test, x test, y test, verbose equals 1. Let's do this. Let's see what happens. Let's see if this blows up. Oh, look at that. Progress. That's so good. Oh, that was great. I love the progress bar. I've written wrappers to add progress bars like any Python for loop I do. It is a world of difference just seeing things like fill up, seeing a little bar fill up like this. It's the difference between, I have no idea when it's going to be done, I'm going crazy, and, ah, yes, I'm doing work. Oh, it'll be 5 minutes? No, I can wait. That's not a problem. So we got back this history object. You don't need to save that off. That actually exists in the model, I believe. I thought it existed in the model. Maybe I'm lying. I could have sworn. All right, you know what? Let's take a look at summary. That's So now, you note the summary. This just gives us a listing of our layers. It says, hey, you've got the dense layer with this many parameters and another fully connected layer with this many parameters. Of course, this last layer is really our output layer because we've got 10 nodes at the end and we're activating with softmax. I thought it was going to tell us what kind of activation we had here. That would have been nice. Oh, well, that doesn't really matter. Did it tell us how we actually did? I was so excited that it finished. Oh, yes. Our validation accuracy was up to 80%, which is actually pretty crummy. Pretty crummy. But it's improving, right? Yeah, it's getting better. I could have sworn validation data split fired or use validation split. We used validation data here, so we're okay on that front. Right now, we're still just learning, so obviously if you were setting up a proper model, you would, of course, split your data properly into a training set, a cross-validation set, and a testing set. Where was that? I thought the history was built into the model. I could be wrong. Maybe that's an old version of Keras, or maybe that's a new version of Keras, and I have the old version. All right, so maybe you should save off your history. Whoa, yeah, there we go. So I have this thing. this history thing. What is this? This is a history over all the epochs that I've done. And it gives me my accuracy and my validation loss, as well as my base, my loss on my training set, and my accuracy on my training set. So that's kind of nice to see. And so you can plot those things if you want to plot them. You can do predictions too if you want to do predictions. In fact, let's copy this stuff. Ding. Let's score this. Even though I think, yeah, so this is just our final, of course, validation score there. But we want to actually look at what's the thing I always want to look at? I always want to look at the weights. And how do you do that in Keras? Well, you can do that with model.getWeights. And this gives you all the actual weights. Isn't that wonderful? That is so good. Let me just save that off to a temporary variable. All right, it's a list. Forgot about that. And you'll note it gives me 4 things, which you might think is weird because we've only got 2 layers. Recall model.summary. Of course, you can look at model.summary and you're like, well, it counts 4 layers there. Right. We got dense, we got activation, we got dense, we got activation. That's not the 4 coming out here. This 4 is because we've got weights associated with the inputs to this dense layer, plus the bias. So that's what there's sort of 2 for each layer of interesting things. Because I can say a of 0.shape, 784 inputs, 128 outputs. And I can say a of 1.shape, and I'm predicting 128 outputs. Bam. 2 is going to be 128, 10, and 3 is going to be 10. Look at that. I can see into the future. It's amazing. So what you can do is you can just save off these guys, model.getWeights, into your local area. And then if you want, what is W1 and what did I say that was? You can, all right, now here's when I need to look at my old skflow. Right, to see how I visualize these weights. TensorFlow, skflow, no, skflow tutorial, there we go. Right, that's what I wanted to do. I wanted to steal this stuff, I think. Num layers. I think that's what I wanted. I'm always all about visualizing the layers. You'd think I would have figured it out by now. There's 10 layers. Plot.subplots. Well, that's for number of layers. That is not at all what I wanted. I just wanted the initial 10. Just the initial 10. Final layer for subplot. Ah. You think I would have figured this out by now. Subplot. Where does subplot occur here? 10 by 10? That ain't right. I just need, what, 128 things by 10? You're right, maybe I should just plot.pcolor of this thing. No. 128. Right, that's like 32 times 4, 16 times 8. Right, that's what I want. Let me grab this. That's what I want. None of this num layers business. That's silly. (16 by 8). There we go. That makes much more sense. Instead of being classifier.weights whatever, it's going to be W1. Of all the, let's see. There we go. That should be correct now. Let's see what happens, shall we? See if this actually works. Nice. There we go. Total size new array must remain unchanged. Yeah, figures. XX, YY, W1 of, oh, no, not 10 times that. No. 16 times that. What if I say W1 of 16 times XX plus YY, comma all those, what does that give me? And the length of that? 128. That's not what I expected. Oh, I'm W1.shape. 784 rows, 128 columns, of course. I want to look at all of these things and comma this guy. Right. Give me one of the nodes, all of the rows. One node, all the pixels. That's what I mean. And what did I establish? That plot p-color mesh was faster? Is that what I said? Is that what I convinced myself of? See if I can just use that directly. Let's see, did I use that here? I just used plot.pcolor. Oh! / TensorFlow Sci-Far10. P-color mesh. Yeah, p-color mesh is probably faster. There we go. Let's see how that looks then. I've mixed up my indices here. Just a second. Much better. Yeah, that's fine. Yeah, of course, and that's what it says. Hey, auto balance. Let's just take a much bigger look at this. And this, of course, is not at all illuminating, which shouldn't be surprising. But maybe our output, maybe our final layer is. Let's take a look at that, just for giggles. Let's take a look at our output layer, where we've got 128 nodes and 10 outputs. So here I've got 8 rows of 16 things. So I want 2 rows of 5 things. And I'm going to look at W2 now. This is 5. And, oh, you know what? I don't even want to reshape. I don't want to do that even. I just want to look at that. Yeah. Plot.pcolor mesh. W2. That's the easy thing to do. So of course these are 128 things here. Let's look at that with gray. I like that. CM equals plot.cmap.gray r. I like. I got that backwards, as I am prone to do. There we go. Nothing super obvious strikes out as particular nodes seeming to be associated with particular things. But again, in this model, not that good, so you wouldn't really expect that. Okay, so that was like the world's simplest model, simple neural network model as far as using Keras. There's one other thing with Keras that I definitely want to show off that I haven't really tried myself that much. You can visualize the network, which is something that I've tried to get working in TensorFlow with TensorBoard, you might recall, and well, never did get it working. So I'm hopeful that Keras makes that a little nicer. So if you're using IPython, you can do it in place here. And no module name PyDot. Must install PyDot. Okay. Let's install PyDot. Command yada 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 failed with error code 1. Invalid syntax. Really? So apparently PyDot hasn't been updated sufficiently. Well, that's cute. Alright, that's fine, that's fine. We will not use this method then. We will use this method. Import, well, what are my options for to graph? Oh, I can't use to graph, okay. Keras.utils. It's a special PyDot? Did I not pay attention? Oh, you can also directly obtain PyDot graphed object and render it yourself. Oh, man. Special PyDot. PyDot.ng. How was I supposed to know that? Keras utils. PyDot.ng is a fort of PyDot that is better maintained. I'll believe that. Hang on then. Py.ng. Hey, what do you know? Let's see if this works now. Failed import right, because you must install PyDot and GraphViz for PyDot.print to work. GraphViz. GraphViz. Oh, Graham over here contributed to the original PyDot. Well, thanks for your contributions. That's the only way the open source community gets things done is if people have contributed things. So thank your local open source contributor. Huzzah! Look at that. It imported. All right, now let's see if this really works. That made the object. How do I... Here we go. Directly obtain it and render it yourself. For example, to show it in an IPython notebook. I don't have an IPython notebook open. Oh, okay, hang on. What are my options with A? A, read data? That's not what I want. No. There ought to be a way to graph this. Let me see. To graph. So render py.graph object. Python display is it py.graph, right? Py.graph, yeah. Let's ask the internet how this works. Let's throw an IPython in there. Oh, the Keras viz. Oh, so that's probably why you're checking this video out. eBay shopping category. I did not wish to search eBay. I don't know why that happened. Okay. GraphViz. Oh, GraphViz is a Python thing. I just installed it from... Oh. You used to be able to export to a file. You can still export to a file, it looks like, if you say plot and say to file. I just wanted to be able to plot right in place. I tell you what, though. Let's see if you can't do both. Maybe I don't have to export to file? Function, that's cute. Graph equals to graph. Graph.writePNG to file. So now I got this A thing, right? To graph. Interesting. All right, well, for the sake of argument, let's plot to a file. Just to do that, proj/keras, and there it is. And yep, it's a simple thing with dot. So dot is a Unix tool that will take sort of a textual description of your graph, and I'm using graph in sort of the mathematical sense here, where you've got nodes and you've got edges, and it will convert that into an actual picture. So this is really nice for building graphs to look at for figures, for academic papers, or just for better understanding. because you can build up the textual information programmatically, say, like this, and then you can see the output here. And this isn't super duper informative, but it gives you another picture to look at. And if you had a complicated layer of like, this is dense and this is convolutional and then convolutional and then something else and then this, you'd really be happy to have all that. So here's an interesting thing. I say, let's just spend the remaining time. You can save the graph to PNG. Yes, we just saved the graph to PNG, so that's good. Probably just the stream lag there. B equals, what do I want to do? True graph model. I want to see what this object looks like. B, here we go. Now we got some options. Write SVG, for example. Let's create. What are our options on create? GraphViz is an external tool. Creates and returns a PostScript representation of the graph. Interesting. Create GIF. But I bet if we, for example, hook this into, suppose we did something like this. Someone's working on a way to tie the viz to the wait viz. Oh, that'd be cool. If that was directly in here. I mean, I'm totally fine using matplotlib, just that's what I'm used to. But if there's just a one-line command to say, visualize weights, that would be great. Maybe I'll take a look at that in the code and see if there's a request for that. A pull request. So if I could get, for example, the GIF image, but I can get it in IPython itself and not to a file, then I can just create it in the IPython memory and visualize it right away. Problem is, I don't use PIL that often, and PIL is old to begin with. And I don't super duper remember how to use. Can I import Pillow? Is that something I have? Pillow I know is the more up-to-date version. I don't have that. Okay, we're not gonna worry about it. Let's see. Let's ponder here for just a few seconds. Import pill. What is SVG? How does that work? Create a display object given raw data. Expression or pass to the display function will create the data being displayed. What is B? B.create prog equals dot format equals PNG. Let's see what happens. Alright, so there's my raw PNG data. Pill.image dot. Is there a display kind of thing? I don't remember how to use pill, is the problem. Python pill PNG data stream. No, those are errors. That's not what I want. I just want to display a PNG. Image file formats. Pillow. Pill fork. Oh, no. We're not ready for that just yet. Pill import image. Image.open. So I could pretend use matplotlib image.io to show PNG files. Yeah, that's a good point. But can I pass it an arbitrary string, or do I have to give it a X array like? Yeah, maybe let's try that. Let's see what happens. Of course, X is not defined. Image data I cannot convert to floats. Right. If I converted it to a PNG already, is the catch. You would require image read. Is that in... How does image read work? Read an image from a file into an array. Can I do that? Embedded null byte now. Like, so I could use a string IO to make a, or bytes IO, whatever, to make sort of a bytes object that Python pretends is a file, and it could fiddle with all this stuff. But there's got to be a way to take my PNG raw stuff and be able to read that without resorting to like temporary files of writing it to disk and then reading it off, right? Because nobody wants to do that. Pill import image, but I want to open it. But is that all they use image for? Image, image.open, 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 yada 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 yada. Ah, they're converting. Image, PNG, yeah. EFF bot. Why use PyPNG? I would definitely consider it. PIL dot. I mean, this is all just like to take the long way around and try to visualize this. Image.image, image mode. What are the options? That's what I'm all about. What are the options? Show me the options. Logger, logging, mesh, merge, new. Deferred air effect. Huffman only, image mode, IO. What's IO? Tell me about that. Stream handling. Oh no, this is the default Python one. It's not what we want. Not what we want. Numbers open. I mean, opens identifies a given image file. What if I just pass it in? What if I just tried it? Would it yell at me? Yeah, it does. That's right. Import. Is it bytes.io? Is that a thing? String.io. I think it's capital S. Python string.io. Python 3 string.io. It might be bytes.io now. IO. IO. Yeah, of course I didn't actually read this, so I'm a terrible person. Just import IO. IO dot bytes.io. Yeah. D dot read. No. Trying to do this live, and I don't remember how to use bytes.io from image read import. Yes, I'm image read is a package separately from py.lib, you're saying? Not one that I have. Let's see. Read. Let's see if we can install that. Oh, we can. Okay. Taking a little bit of time. Gotta set it up. Okay. Sorry about that. I thought you meant the version. You found a way to do it in Stack Overflow. Feel free to post. We've got 30 seconds remaining. Can we do this in 30 seconds? Imread dot. No module name image. I gotta re-import, right? Imread dot. Imread. Let's do it. And this can read from some kind of string. Oh, that says file name. Let's see how that actually goes. I don't think that's gonna. That. Yeah, I couldn't identify the file name when we tried imread. Alright, Stack Overflow. This is where it says you can't post links. You can't post links in the chat. That's really unfortunate. I apologize for that, guys. I didn't know. Alright. And of course, I have the chat window open on a separate computer. Because I'm a horrible person. Let's see. 185.22941. Display graph without saving using py.dot. That's exactly what we want. Perfect. Bottom line is no, you cannot avoid creating a file. And yet this guy over here says you can render it by calling graph.dos. Graph is dot without writing any files. then just plot it. It's going to be done assuming G is a pi.graph. Plot.image show image is mpimage.imread. I think that's the magic. And they're using string IO. Okay. Yes. So they're doing just like what I was claiming that we were hoping to do. They essentially fake having a file and then they read the file. And we can see about doing this kind of thing real quick here. Let's see. This is going to be io.stringio. This is going to be C. String.io. Oh, bytes IO maybe. There we go. I gotta get mp image. Oh, matplotlib.image. Oh yeah. Let's use that real quick. And now we have something that we can read with, of course, plot.image show image. And there you go. So that was a roundabout way to view the image, but we didn't have to save it to a file. We just had to pretend to save it to a file using this bytes.io. A bit of a hacky workaround, but that worked. And that's all just to do this silly little visualize what the model actually looks like business, which is not at all required, and that's just a nice thing to have. The point was, it's pretty easy to specify a model in Keras with this sequential, just saying model.add a dense layer. Tell me what activation what is. Add another dense layer. Tell me what activation is. How are you planning to do your gradient? Okay, now compile it. What's your loss function? Oh, it's probably one of these. Okay, now fit it. Just like we did sort of with scikit, with skflow or scikit-flow. Very similar fit style. And here, look at how easy it was to get the weights. That was so nice. I really liked that. Downside, don't know how to do a custom activation function, / that's going to be really complicated. Maybe we'll try to do that next week. We'll definitely be back next week with more Keras. I might try a more complicated model just to see how it handles that. We might fiddle around more with these kind of visualizations, but probably not too much of that. Again, if there's something that you guys really want to see, let me know. Send me an email, leave a comment. Someone commented that they wanted to see Keras, and that's how this happened. I post to Reddit under r/machine learning. You can find my post there. Upvote, downvote, leave comments, whatever you want. I'm on Twitter, all that jazz. Thank you guys very much, especially people in the chat who are helping me figure this stuff out, and we're all learning together. So thank you very much. You guys have a good night.